Alright, we just made the crowded sparse TIFF, and I'm actually going to move this to my scratch folder. This is an older one that I made. I'll just get rid of that. So with my crowded sparse, what I'd like to do now is create my kind of near far raster. And near far is going to be my categories in the same way that this is showing me where the crowded places are and where the sparse places are. I'd like to have a classification that shows me, using my proximity TIFF, kind of go from near the coast to far away. And let's just have anywhere, we'll say 5 miles from shore will be near, and then over 5 miles from shore will be far. So to do that, we've got these values, but of course these values here are actually in meters, right? So the first thing we have to do is go here and say how many meters in a mile, and it tells us there are 1609.34 meters in a mile. So I think what I want to do is we'll use that number and we say five times that, we get 8,046 or 46.7. So I'm just going to go 8,047. That's pretty good. So we say proximity less than 8047 is going to be a, actually let's just call this a 1, right? And that's near, which is quote unquote, that's good. But we also care about places where proximity is greater than or is greater than or equal to, just to include that one value there, 8047. Let's make this worth 2. So we're creating kind of these nominal classes, right, or ordinal classes, near and far. So that should be good. Let's see if that works. And I'm going to call this one in my scratch folder. I'm going to call this near far. Okay. That looks pretty good. Say OK. And if we bring in the mainland, we should be able to see, yes, good. So it kind of goes on the outside, near and far. So that's pretty good. Cool. So before I get too excited and go ahead and just add these together, I want to create a constraint based on this. We found out that when we're looking for haddock, or we're looking for bottom fish more exactly, we're looking for cod and haddock, we've got these ranges 120 to 250 and 150 to 200. This range right here of kind of the depth that we're most likely to find these fish is within this, right? 120 to 250 is a wider range that also includes this range. So let's just create a Boolean, just a true false, that we can multiply. We only want to go to places where we're sure to find both of these. So because this is within that, I'm just going to use this range, 150 to 200 feet. And this is below sea level. So I'm going to create a Boolean from my relief raster, my topographic and bathymetric relief, and create a Boolean where all of this equals 1, so that I can kind of I can create a constraint and multiply my expression by that. So you'll see what I mean in a moment. I want to bring my projected relief here, and I want to reclassify this raster so that only 150, sorry, what was it? Only 150 to 200 feet below sea level, those are the only places that are going to be acceptable to look for fish, or the type of fish we're looking for. I could just do a unit conversion in my classification system, but I'd rather it's kind of my preference to just multiply this whole raster by a constant value so that I can have the vertical units, which I know are in meters right now, to kind of turn into feet. So then I can do my classification of the fish kind of depth classification. So I'm going to go up to my Raster Calculator and take my relief, my projected relief here, and I just need to multiply the whole thing by a constant value. And of course I can just go up here and say how many feet in 1 meter, and I get 3.28, so that's good. And I say okay, like that. I'm going to say this new file, I'll keep it as source data, and I'm going to call this relief underscore ft for feet, so that I know the vertical units are in feet. The horizontal units I'm pretty sure are still in meters, but I could check that if I wanted to. So I say okay, that looks good, say okay, and there it is. Now it looks exactly the same, but the hopefully you can see that the units have changed here. And if I wanted to look at the actual min and max, oops, I could look at the actual min and max here. One way to do that is hit load on min and max, and yeah, 1200. That's about the height of Maguntacook, so I know that's good. Okay, so I've got that, and now to do my classification, check one more time just because I'm as forgetful as a goldfish. Yep, 150 to 200. So we're only looking at a 50-foot range here, but 150 to 200. So I really want my raster calculator where the relief in feet is greater than 150, right? So that's going to return a true value. And I can I'm going to say or relief in feet. Sorry, this should be and, right? Both of these must be true for my expression to come through the way I want it to. 200, right? So if this is true and this is true, I'm going to get a narrow band of pixels that represent that 50 foot interval. If I did or, then the entire raster would return true, because the entire raster is either greater than 150 or less than 200. So that would be kind of foolish. And and or statements are simple, but sometimes it's easy to mess them up. So this is good. I'm going to call this one in my scratch folder ideal depth. And that's just going to return a 1 value for the ideal depth and a 0 for things that are not ideal. So now I say OK. And that's a pretty narrow band, isn't it? That is pretty narrow. Oh, you know what I also did that was wrong? This is good. I did this before, and I'm kind of glad I didn't correct myself, because you might not notice, but what I just did there was I forgot to include the negative sign. So this is all above this is above the shoreline, because 150 and 200 are above sea level. I need to do below sea level. So I'm going to go back and try that again. I'm looking actually for this that is, and this is where it gets tricky, it's actually less than negative 150, right? Because less than means it will get lower than that, even though 250 seems like it's a bigger number or 200 is a bigger number than 150. It's still less than 150 in the negative scale. So this might be a little confusing, but I'm hoping you can figure it out. Greater than negative 200. So this should actually return what I want. And take a look at that, and hopefully it can make some sense to you. And let's call this file ideal depth 2, because it's my second try. Hopefully this is the right thing. I say OK. Yep, that's way better. And if you take each of these files independently and compare them to the mainland, you'll see that, yep, these are depths in the water, whereas these are heights above land, and these are heights on islands, right? So I'm just going to remove the first ideal depth, and you could even go and delete it, probably. That would be a good idea. So I'm ready to do my, my conditional adding. So go on to the next video, and you'll check that out.